We're at gotomath.com doing some calculus, and let's go down to the MVT, most valuable theorem. No, just kidding. Most valuable theorem. Mean value theorem. And looks like we've only got one problem here. I'm sure we'll eventually add more, but this at least gives you an idea of what's going on, okay? So let's just click on that and see what's up with the picture. Let's read this. Determine if the mean value theorem can be applied. Okay. First off, h of x must be continuous on this interval here, and it must be differentiable on the open interval. That means that we wouldn't include 2 and 12. So that's also true because it is a polynomial, for one thing. And they're continuous and differentiable everywhere. Now, we got two lines here. This, if we looked at h of 2, that's where this red dot's at, and if we looked at h of 12, we'd see that's where this red dot is at here. And we're finding the slope. You see this line right here? This is the secant line. The secant line, the slope of the secant line. Now, we're going to find a line, a tangent line that's parallel to the secant line. As you can see, they both have the same slope. But we want to find a c somewhere between this, somewhere between 2 and 12. There exists a c so that when we plug it into the derivative, we get the same slope as the slope of the tangent line or secant line. Well, let's hurry and go to the board. Let's write this stuff down first, I guess. Okay, so we want to find the slope of the secant line. Let's do that first. All right, find the slope of the secant line. So we're going to have to hurry. Don't have much time. We have h. Is it h again? Are we using h's again? H of x is equal to x squared minus 12x plus 27. And we're on that interval between 2 and 12. Okay. So let's pretend this says A and B here, and more generally we're looking at h of B minus h of A. See, this is going to be the slope of that secant line, you see, and then B minus A, and then we're going to set that equal to, so that's the slope of the secant line, but when we take the derivative, we're going to plug C into it, and that derivative, the slope, oh my gosh, anyway, this is going to be the slope of the tangent line at C on that curve, which is going to be equal to the slope of the secant line. So there's our equation right there that we need to actually set up. All right, so that's going to be h of 12 minus h of 2, and that's all over 12 minus 2. And then I'm going to go ahead and just take the derivative and plug C into it. How's that? Now that's the derivative of this guy up here, okay? Alright, so I'm going to pause the video, work this out, try to save some time, work part of it out, and you pause the video and work it out. Okay, so h of 12 I end up with 27, then h of 2 I end up with 7, and of course 12 minus 2 is 10. And then I'm going to continue to write this over here like such. Alright, let's just continue this over here. So we have 27 minus 7 is going to be 20 over 10. And so we end up with 2. And so this looks like this is going to be 2 plus 12 divided by 2, and 12, 13, 14, so that looks like that's going to be 7, and so therefore C is equal to 7. Let's move back over to the web page, and so C, this would end up being 7 right here. It says round answer to 2 decimal places, and we just throw some zeros on the end there. Alright, pretty easy, and I'll see you back there. Bye.